Every version of HTTP was created to fix one specific kind of slowness in the version before it. The story of HTTP is really the story of fighting one enemy: blocking. A modern web page loads dozens or hundreds of files. The way those requests share a network connection decides whether they race in parallel or wait in a queue. HTTP/1.1, designed in 1997, was never built for pages with 100 requests, and the workarounds it forced created a generation of performance hacks. HTTP is the protocol that defines how a browser asks for files and how a server replies. Each new version changes how requests are packed onto the underlying network connection, and that packing is where the speed lives. The core problem each version attacks is head-of-line blocking, where one slow item stalls everything behind it. HTTP/1.1 sends one request at a time per connection and must wait for each response before sending the next, so a slow file blocks the queue behind it, the original head-of-line blocking. To work around this, browsers open up to 6 parallel connections per domain, and developers shard assets across multiple domains and bundle files together to dodge the limit. HTTP/2, standardized in 2015, introduces multiplexing, sending many requests and responses at once over a single connection by splitting them into interleaved frames. HTTP/2 also compresses headers with PAC and lets the server hint priorities, so a small connection carries the whole page in parallel instead of 6 at a time. But HTTP/2 still rides on TCP, and TCP delivers bytes strictly in order, so if one packet is lost, every stream waits for the retransmit, recreating head-of-line blocking at the transport layer. HTTP/3, standardized in 2022, drops TCP entirely and runs on QUIC, a new transport built on UDP that treats each stream independently, so a lost packet only stalls its own stream, not all of them. QUIC also folds the connection setup and the TLS encryption handshake into a single round trip and can resume a known server in 0 round trips, cutting startup latency sharply. Before HTTP/2, sites like Google spreadsheeted dozens of icons into one image and concatenated all scripts into one file purely to beat the 6 connection limit. After HTTP/2, those tricks became unnecessary or even harmful because many small cacheable files now load in parallel over one connection. With HTTP/3, a user on a flaky mobile network sees the biggest gain, since a single dropped packet no longer freezes the entire page the way it did on TCP. A common misconception is that HTTP/2 made bundling pointless. In practice, a balance still matters, because very many tiny files add per request overhead even when multiplexed. Another mistake is assuming HTTP/3 is just HTTP/2 with a faster handshake. The real change is the move off TCP to QUIC, which is what finally kills transport-level head-of-line blocking, the one thing HTTP/2 could not solve. HTTP/1.1 queued requests. HTTP/2 multiplexed them over one TCP connection, and HTTP/3 moved to QUIC over UDP, so a lost packet no longer blocks every stream. Each version targets head-of-line blocking at a deeper level. I trace one real piece of web technology to its roots every day on this channel, so subscribe to Tech with Joel for the series. Now tell me in the comments, which HTTP version is the site you visit most actually running on? Subscribe to Tech with Joel.